This is chapter 4, section 3, problem number 7. It says a velocity of an object moving along the x-axis, and it's a piecewise linear. So it was going forward, then it was going backwards, and still going backwards, and now going forward. So it's moving along the x-axis. And it's moving right when it's positive. So it's moving right, and then it's moving left, and then it's moving back right. Write an expression involving definite integrals whose value is the total change in position of the object. Well, that's simply going to be the integral from 0 to 4 of this velocity graph, the area under this graph dt. But if we wanted to be more clever than that, we can see that v is a straight line for a while and then a straight line for a while. So we could also say it's the integral from 0 to 1.5. It's this line, which is a slope of -2 times t through a y-intercept of 1, or vertical intercept of 1, dt. That would give us the area under this portion of the graph, this area and this area. Plus, then we would have the area from 1.5 to 4 of the graph, this graph, which is slope of +1, so it's t plus, or actually minus, because if I move over here, it's -2.5, -3, -3.5. So this would be a better description of it, but that's basically what this would be. Since this has got two different separate graphs, we would do it in two separate pieces, thinking of it as this piece and that piece. Use the provided graph to determine the total change in position. Okay, so we just got to figure out the area. So half wide, 1 tall, this rectangle would be a half, and so that's a quarter. Positive. That's 1 by 2 is 2, but half of it, so this is -1. This is 2 by 2, which would be 4, but we only have half of it, so it's -2. Minus because it's below. And this is a half by a half, which is a quarter for the square, so it's an eighth. So the total change in position is -3 plus 3/8, which is -2 5/8 feet. Because we're taking seconds times feet per second. Write an expression involving definite integrals whose value is the total distance traveled. So now we want these to be positive. So we're going to do, I'm going to write it out all out. So I'd have to go from 0 to 0.5 of -2t plus 1 dt. That would get this area. This area is minus, so I need to change its sign. So I'm going to subtract this negative area from 0.5 to 1.5, 0.5 to 1.5 of the same equation, -2t plus 1. So I'm turning this area into positive area by subtracting it. that negative area. Subtract the negative to make it positive. Then I got this negative area, so I'm going to subtract to make it positive, and the integral is going to be from 1.5 to 3.5 of this equation, t minus 3.5. This area is negative, and so I'm subtracting it to make it positive. And finally, I have this, which is already positive, so I'm just going to add in from 3.5 to 4, the area under t minus 3.5 dt. So this was a positive area. This should be the 1/8. The negative, this should be -2, and I got to subtract the -2. And this is negative, and this area is -1. So I got to subtract the -1, and this area is 1/4. So I end up with 1 plus 2, which is 3, plus 3/8. So the total distance is 3 3/8, the feet that the thing has traveled, but it's only 2 5/8 feet from where it started. So what's the average velocity? So that's the change in position over the change in time. So we're trying to figure out how many feet per second it has to move every second and in what direction to end up where it did. So we're going to take the total change in position, -2.5/8 feet, divided by the total time, which was 4 seconds, and this would give us the average velocity in feet per second. I'll let you figure out how to get that into a decimal form or fraction form for putting it in, if you want to check your answer. Find the algebraic formula for the object's position on the interval from 0 to 1.5. So, algebraic formula. So, from 0 to 1.5, its change in position will be this. And now, to do the antiderivative of this, we have to figure out what would we take the derivative of to get -2t, and that would be -t squared. And what would we take the antiderivative of to get 1, and that would be plus t. And then we would, if this is our function for the position, plus c, because we don't know where it starts, then to figure out how far it's moved, we would put in 1.5. Well, actually, this is the equation, and then they want us to make sure that when t is 0, we get the distance is 0. So I put 0 there and 0 there, and I'm supposed to get 0. C would have to be 0. So for the first 1.5 seconds, the position equation is negative t squared, that is negative because of the -2 there, negative t squared plus t. That would be the position equation.